Alright, today we're going to go over how to find intervals of increasing, decreasing, positive and negative, and zeros for a quadratic function. So we're going to start out with the zeros. All the zeros are the x-intercepts of your graph. So all the points where you cross the x-axis, they should be of the form some x value, and the y-coordinate of a 0 is always 0 because it's the x value that makes the equation equal to 0. Now, in terms of where a graph is increasing and decreasing, what you want to do is you want to trace your graph, or think about tracing your graph from left to right. And as you're doing that, if you're going down, you're going to be decreasing, and as you're going to go up, you are increasing. So on a quadratic function, if I'm going this way, this would be decreasing. And if I'm going this way, I would be increasing. And I can stop. We are going to work on two different graphs here, one that's turned right side up and one that's turned upside down, so you guys can see the difference. Another way in terms of a parabola will be if it's flipped over. So these two will go for our first graph, and then we'll talk about the second. So I have a graph for you guys already. And so we're just going to identify a couple of things at the top before we do any increasing and decreasing. So I'm going to identify the vertex real quick, and that's going to be, looks like 5, -4. Axis of symmetry is always just the vertical line that goes right through the middle, cuts the graph into two equal pieces, and so that vertical line is x equals 5. Domain for every single quadratic goes left and right forever, so -infinity to infinity. Now the range, I'm going to approach this from the bottom. The first point I would touch, the first y-coordinate, would be -4. That's going to have a bracket on it. And then the rest of the graph goes up forever, so positive infinity. And increasing and decreasing is where I'm going to grab a highlighter here and hopefully make this make more sense. Okay, so I'm going to trace the graph just starting over here, and this is the left side. So as I'm tracing this whole time I'm drawing down. So that whole part of the graph is decreasing. Sorry about that. Alright, now I'm just going to grab a different highlighter. And at this point where we're on the vertex of the graph, you're neither increasing or decreasing because it's just flat right there. And then we're going to go on this piece, and as I'm tracing there, sorry guys, my computer wants to do a bunch of updates right now apparently. And this guy is going to be increasing because I was tracing up. Okay, now on the graph here, I'm just going to draw a little note. All the way to the left would be -infinity. Okay, when you do increasing and decreasing, it's always based on x values. So I'm just going to draw a little line. This whole time the graph is decreasing, and I stop decreasing and I'm just kind of flat at an x value here of 5. Now the rest of the graph is increasing, and that's going to go forever to positive infinity. So here's how I'm going to write my intervals. My increasing, I start increasing at 5. Now remember I mentioned to you, I'm not increasing or decreasing at that point, it's just flat, so I'm not going to use a bracket there, I'm going to use a parenthesis. So I'm going to say from 5 to infinity, we're increasing. And then back here, I'm decreasing from -infinity until I get to that 5. Again, both of these have parentheses. And then all you have to do for your zeros is identify the places where the graph crosses the x-axis. So you have a cross at 1, 0, and you also have one at 9, 0. Pause this at any time if I'm going too fast. I'm going to slide this up and do increasing and decreasing on this graph. Okay, again, I got my vertex, and this is at 1, 9. My axis of symmetry is just going to be x equals 1, going right through the middle. Domain, every single one, negative infinity to infinity. Now, the range here, if I'm approaching from the bottom to get my lowest value, I can see that this graph points down forever. So I'm going to start with negative infinity because the graph goes down. And I just realized, sorry guys, my vertex is 1, 8. As I'm doing the range here, the last point I touch is that 8. And that's going to have a bracket because we actually have a point there. Okay, now I'm going to jot down kind of what I did last time. This all the way to the left forever would be negative infinity. All the way to the right forever would be positive infinity. Now, if my parabola is turning upside down, you're still going to go from left to right. As I'm tracing here, I'm going, and I just used the same color, I'm going up, so this is increasing. And on the other side, after I get to the vertex, then the rest of the graph is going down. So this would be decreasing. So, as I'm writing these intervals for myself, this whole time until I get to the x value of 1, I'm increasing. And then from 1 to infinity, I'm decreasing. So I'm just going to jot down those intervals. For increasing, 1 to infinity. Remember, I'm using a bracket, or I'm sorry, a parenthesis here because at that top point, at that vertex, you're not increasing or decreasing, you're just flat. And then the interval for decreasing is from 1 to infinity. Sorry guys, I gotta back up. My increasing, I was doing the decreasing. Increasing negative infinity to 1. This is increasing because I'm going up. This is decreasing because I'm going down. Alright, now on the back here we're going to focus on where a graph is positive or negative. So, graph is positive when the graph is above the x-axis. This means all the y values are positive. And then you are negative below the x-axis. This is wherever your y values are negative. And again, just like the last one, when we write the intervals here, they're going to be based on x values. They're never based on y values. So I've got two graphs to practice with here again, and I'm going to use my highlighter to help kind of focus where these intervals are positive and negative. So just for the vertex, and actually this might be the same graph we were just working with. This is 1, 8, axis of symmetry, x equals 1. Domain for every single graph, negative infinity to infinity. Now the range here, you go down forever and it gets stopped at 8. Now on a graph where you're trying to determine positive and negative, that is going to change where the zeros are. So we're going to identify these zeros real quick. So I have -3, 0, and I have 5, 0. Okay, so I'm going to grab my highlighter. Where the graph is above the x-axis is considered positive. And wherever your graph is below the x-axis, where the y values are negative, is considered negative. So this piece would be positive, and down here we actually have two pieces that'll be negative. Okay, so I'm going to kind of do the same thing I did on the front. This is not an axis of symmetry, but I'm just kind of drawing up here. These are where I switch from positive to negative. So all the way to the left is negative infinity. This whole time I'm negative, and I switch over at -3. This whole time I'm positive, and I'm going to switch over at 5. And then the rest of the graph is below the x-axis, and so that's going to be negative. So here's how we're going to write these intervals. Okay, the positive interval here is just this little loop, and that goes from -3 to 5. And again, I'm using parentheses because at 0, 0 is not considered positive or negative, and so we want to just have a parenthesis there because at that point, you're neither considered positive or negative. Okay, now for the negative, from -infinity to that -3, I have this little piece here is below the x-axis, that's negative. At the -3, that's where we switch back up, and then here at 5, you go back down. Now, if you have more than one interval, we're going to use this symbol in between, it means union. It's just a fancy math symbol that means like for both of these intervals is what it means. So I'm going to put the union symbol in the middle because this is for both. My other negative interval, if you guys are looking at my little note up here, it goes from 5 to infinity. Starting at the x value of 5, and then for the rest of the graph, it's going to be below the x-axis. Pause this at any time if I'm going too fast. Okay, I'm going to run through and tell you the vertex, which is -7, -9. The axis of symmetry is going to be x equals -7, right up the middle. I'm not going to draw on this one. All these graphs go left and right forever. So the domain is going to cover all real x values, which is -infinity to infinity. The range, the first value you're going to touch is that -9. The rest of the graph is above that, so -9 to infinity for my range. Now, the zeros are really important when you're doing positive and negative intervals. So -13, 0 is this 0 over here. And -1, 0 is our other value. And on this graph, these two pieces are positive because they're above the x-axis. And here, this whole loop down here, all these y values down here are negative. So here's what we're going to do. I'm not going to draw the axis of symmetry on this one. I'm just going to kind of draw up. These are the two places the graph switches from positive to negative. So at -13 and -1. Now I know this is really far over to the edge, but all the way to the left would be -infinity. Got this whole loop here. These pieces are negative, this little piece is positive, and the rest of the graph is positive. So my positive intervals, I have two here. To the left forever, this would be above the x-axis, so from -infinity to that -13, and at the -13, that's where we switch over. But there's another positive interval, so I'm going to put union here. Now this positive interval starts with the x value of -1, and it's going to go to the right forever. I know it's going up forever, but that's the positive part. We're talking about the x values. The rest of that graph will be above the x-axis, so that goes to infinity. All right, and then finally, here, this little negative loop, everything from -13 to -1, all those points are below the x-axis. So that interval is going to go from -13 to -1. And then I just have a quick kind of special case. So if you guys will notice, I have a graph here, and you only actually have one 0, and that's the vertex of the graph, which is 5, 0. So I just wanted to show you this little special case. Now, this entire graph, with the exception of the vertex, because it's touching the x-axis, the entire graph is above the x-axis except for that point that is touching the x-axis. Okay, so none of this is negative, but there's actually two intervals that you have to define here, because at this point right here, remember I told you guys that if it's touching 0, it's not considered positive or negative. So you actually do have to write two different intervals here because at that value of 5, we're touching the x-axis, so it's not considered positive or negative. So, little special case from negative infinity to 5, and then union 5 to infinity. It's just a little technicality because the vertex is not considered to have a positive or a negative y value. It's 0. So you have to write two different intervals there to cover that whole graph.